Okay, I want to go through this part of the final review that involves college algebra. So I'm just going to go through this packet with you and look at each one of these types of problems. First of all, under the heading of functions, we want to be able to find the domain of functions. Now, remember, with domains at this stage, when we were just introduced to functions, we concerned ourselves with two cases. When you have a variable in the denominator, like this first one. So I'm looking at 1a here, where we have f of x equals 2x over x plus 5. Our concern in this case is that we never try to divide by 0. So we don't want to put in anything in place of x that will give us a 0 in the denominator. So what we do is we say, okay, I'm going to do some investigating and find out what's going to make that denominator 0. Well, whenever x plus 5 is equal to 0. So that means that x cannot be equal to negative 5. That's our domain right there. Now, the way we'll write that is we'll write that as negative infinity to negative 5, jump over it, and go from negative 5 to infinity. This is the interval notation. Now, our next concern is that we never try to take the even root of a negative number. In other words, I don't want to find myself where I'm plugging in to the function and getting the square root of a negative 2 or something like that. So that's like part B. 1b, where we're going to say, okay, I want to make sure that the radicand x plus 5 is always greater than or equal to 0. So that means that x has to be greater than or equal to negative 5, and we could write that as negative 5 to infinity. And notice that I'm including the negative 5 as part of my answer because we could have the square root of 0. Now notice, if you have the cube root, we don't have any worry. We just say, okay, the domain is all real numbers because we can take the cube root of a negative. If it's the fifth root, if it's any odd root, we're good with that. Okay, now let's look at simplifying the difference quotient. Okay, so we're looking at problem number 2 here. So here's what we need to do. When we talk about simplifying the difference quotient, we're talking about really just evaluating the function, whatever function we're given, f of x, and putting it in this form right here. In other words, we're going to replace the x's with f of x plus h. So let's look at this first one, 2a. Notice my function here is f of x equals x squared plus 2x plus 3. So here's what the difference quotient is going to look like. We're going to have x plus h squared instead of x squared plus 2x plus h plus 3. And then we subtract off the entirety of the function just with x. So x squared plus 2x plus 3. All that over h. And when I talk about simplifying the difference quotient here, this is all I'm talking about. Multiplying everything out, gathering like terms, and then maybe seeing if you can divide out this h on the bottom. So that's what we're trying to do. So if you go through here and work through it, you'll get x squared plus 2xh plus h squared. That's this part. Plus 2x plus 2h plus 3, and then subtracting off the x squared, the 2x, and the 3. It's important to put minus the whole function in the parentheses. Now, after we do that, you'll notice some things cancel here. The x squareds cancel, the 2x cancels, and the 3's cancel. So then we look and see what's left. We've got 2xh plus h squared plus 2h. And I guess that's it, right? All over h Now we factor out an h. And we cancel the h out. So there it is. We've simplified it. 2x plus h plus 2. Now later on, when you study calculus, you'll talk about limits, and you'll look at, well, what happens if you let that h part get infinitely small? You'll let the h go to 0. But right now, this is all we're doing. We're just working on our algebra skills on this. Now there's another one here, part B, where we have the f function is x cubed. Okay, so let's look at that one. So we have x plus h cubed minus x cubed over h. Now remember, what the important thing here is to know how to multiply out the x plus h cubed. And in fact, we've got different methods for doing that. One, remember, we have the Pascal's triangle to generate the coefficients, where we make a triangle of ones, and then we add the numbers between. Or we add the numbers to get the numbers between. So notice 2 and 1 is 3. Add this number and this number to get this number. And then, so this is Pascal's triangle. Now notice what this gives us. This gives us the coefficients. This one right here, notice here's 0, 1, 2, 3. This is a third degree power function. So this one is going to give us the coefficients. Here's what we've got. X plus h cubed. Okay, that's going to be x cubed plus, that's 1x cubed, plus 3x squared h. See, we count down now. 3, 2, plus another 3, 3xh squared. And then finally on the end, h cubed. See, it's 1, 3, 3, 1. So the exponents go 3, 2, 1, and then 3, 2, 1 going back the other way. And then, of course, minus x cubed. And once again, we have some things canceling out. The x, well, just these x cubes. And then we have this. We have 3x squared h plus 3xh squared plus h cubed all over h. And when we factor out the h and cancel, all we're left with is, let me see if I have room here. We have 3x squared plus 3xh plus h squared. Okay, so there, I hope you can see that. Okay, so there it is. So we have simplified the difference quotient. Okay, now on to the next part, where we want to determine if a function is even, odd, or neither. Okay, so here we go. Okay, so we're on this part right here, number 3. A function is even if replacing the x with a negative x makes no difference to the value, the output. So if you look at this function right here, if I put in a negative x, I get negative x squared plus 2 times negative x plus 1. Now, notice the first term stays the same. It's x squared. However, the second term gets changed to a negative. Now, the fact that x squared minus 2x plus 1 is different than x squared plus 2x plus 1, the fact that those are different means that that's not an even function. Now, it could be an odd function if replacing the x with a negative x will give you exactly the opposite value. So here's the deal. A function is even if this is true, if that's true. A function is odd if this is true. Okay? Now, A is going to be neither even nor odd, and you can test that out. You can put a negative x in there. Let's look at this next one. Let's suppose I put a negative x in. So I've got negative x cubed plus 2 times negative x. Now, this is going to, a negative number raised to an odd power, that's going to give me a negative. So I get negative x cubed minus 2x. Ah, look at that. That's exactly the opposite of the original function. Therefore, that function is definitely odd. And when it's odd, it means it's symmetric about the origin. Okay, now let's look at this last one here. I'm going to put in a negative x. I get negative x to the fourth. Raise a negative to an even power. That makes it positive. 2 times negative x squared. That's going to be positive. So look, here's what we've got. We've got x to the fourth plus 2x squared plus 3. That's exactly the same as the original function. Therefore, this function is even. And that means the graph is symmetric about the y-axis. Okay, now, as far as finding inverses, so let's think about this. We want to find inverses of functions. And what we're going to do, we're going to rewrite. So remember, we rewrite the function. Okay, so for example, this first one, I'm going to write it as y equals 3x minus 1. You interchange variables. In other words, I replace the y with an x and the x with a y, and then you solve for y. See, right here we've established the inverse relationship, x equals 3y minus 1, but then we have to solve it for y, to get it back in the form where it's y is some function of x. So now we have y equals x plus 1 over 3. And there's the inverse for that first one. So that's A. So remember, every time we rewrite, we interchange. We solve for y, and then we rewrite it. So probably I would need to say f inverse of x equals x plus 1 over 3. Okay, so this first one, or this part B, notice we have x equals y cubed plus 7. And now I want to solve that, so I get x minus 7 equals y cubed. And that means that y equals the cube root of x minus 7. There. So that's how we do every one of these. We interchange the variables. So if you look at this one here, this is going to be x equals the cube root of y plus 3. I'm going to cube both sides, so I get x cubed equals y plus 3, and then I subtract the 3. So we end up getting y equals x cubed minus 3. Yeah, that's it. Okay, now, let's suppose that we've got a couple of functions and we want to demonstrate that they are inverses of each other. Well, functions are inverses of each other if this is true. If f of g of x is equal to g of f of x, and those are both equal to x, when that happens, we say, okay, those two functions are inverses of each other. So let's see how this goes. Let's try this first one, f of g of x. Okay, so we have 2, leaving a blank where the x is, plus 5, and I'm going to put in the g function, which is x minus 5 over 2. Okay, well notice when we do that, the 2's cancel, and I'm left with x minus 5 plus 5 equals x. Ah, good. So that gives us good evidence that those two are inverses. We can really nail it down by going the other way, though. G of f of x. So here it goes. Blank minus 5 over 2. And then this is 2x plus 5. Simplify the top and we get 2x over 2, which equals x. So there we go. We got it. So we've established for part A that those two are inverses of each other. And we do the same thing for part B. All these are the same. So we've got f of g of x. Okay, here we go. Blank cubed plus 5. The cube root of x minus 5. And that is just going to be x. Okay? Because we cube a cube root, and then we just got x minus 5 plus 5. We can go the other way too. G of f of x, and that is the cube root of x cubed plus 5 minus 5. And you can see that's x as well. Okay, now, those are the highlights of what we need to know about functions. It's not everything we need to know about functions, but as far as what I'm going to focus on for this test, that's where you need to zero in on this stuff. Now, we left functions and we start looking at specific type of functions. One is the polynomial. So let's look at this. For part A, okay, so let me just do a quick sketch. And this is a rough sketch now. Notice this has roots at -5, 1, and 2 right here. So I'm looking at A. So here's -5, 1, and 2. Okay, so the factors are x plus 5, x minus 2, x minus 1. So the roots are -5, 2, and 1. Now, those are the x-intercepts here. We also have a y-intercept, and we find that by letting x be 0. So we get 5 times -2 times -1. And we get 10. So up here. Now, I'm just going to start here at the y-intercept and kind of trace it through like that. Just bounce through like this. This is just meant to be a rough sketch, very rough sketch. But this is like A, okay? Now, let's look at B. Okay. On B, we have, once again, we find our roots. We've got -2 right here, and we've got +1 and +2. Now, the thing is, notice that this right here, this 2, that indicates a multiplicity of 2. And from a graphing point of view, that means the function is not, the curve is not going to pass through the graph. It's going to bounce off of it. Now, as far as the y-intercept goes, that's going to be 8. See? -2 times -1, that's 2, times 4, which is 8. And we're going to have something that looks like this. It's going to bounce, and it's going to pass through the graph here. Okay, there we go. So that's that one. Now let's look at C. So this is B. Now C. Okay. Let's make a little graph. Now this one, we can't readily see the factors because it's not factored. However, we could factor this. I factor out an x, and then I see that this can be factored as x plus 2, x plus 5. So we factor it completely. First factor out the x, and then I've got x squared plus 7x plus 10, and I can factor that. And then you notice what we have here. We have 0 is a root, -2 is a root, and -5 is a root. Now, 0 is also a y-intercept. So we're going to start at the y-intercept and just trace through, but the question is, do we go, which way do we go? Do we start here and go up, or do we start here and go down? How do we do that? Well, you have to realize this is when you have, let's look at this. We have an even degree and an odd degree polynomial. We have a positive leading coefficient and a negative leading coefficient. When you have an even and a positive leading coefficient, the extreme left and right behavior is this way, up and up. When it's odd, it goes down and up. That's if the leading coefficient is positive. Now, if the leading coefficient is negative, everything is flipped. So this one is an odd degree, and it's positive, so it's going to go like this. You know, very rough sketch. Okay, now, then we go the other way. We say, okay, well, I want to write an equation. Now, you know, from the graph. So look, here's what we have. We have this function. And I'm going to put an A here because I want to be able to contort this thing and make it pass through that particular y coordinate right there, where it passes through the y-axis. But I first of all look at the factors. Here's a -2, so that's going to be x plus 2. Here is a 1, so that's going to be x minus 1, but it bounces, so I'm going to square it. So there it is. Now, this is a polynomial that will pass through those points. However, I want to make sure this thing passes through the point 0, 2. So let me put a 2 in here and a 0 over here. And if I do that, I see that a is equal to 1. So my polynomial is just going to be x plus 2, x minus 1 squared. Okay, now let's look at this one. This one here doesn't have any bouncing. Let's see here, it passes through -5, so this is going to be a x plus 5. It passes through 1, so this is x plus 1, passes through -1, and it passes through +1. And it has a y-intercept of -5. Well, it looks like this is going to, again, just give us a value of 1. Yeah, so we got -5a equals -5. So a is equal to 1. So it looks like I chose some simple ones on that. But you always need to figure out what a is. Okay, now, next, let's suppose we're given a root and we want to use division to find the other roots. So in this case, 8a, we've got x minus 3 as a root, okay? So that means, or x equals 3 is a root, then that means that x minus 3 is a factor. So let's look at that. X minus 3. Okay. And we're going to divide that into x cubed minus 3x squared minus 4x plus 12. Okay? Now, let's see what happens. X will go into x cubed, x squared times. So that means this is going to be x cubed minus 3x squared. Okay? No worries. I subtract. Comes down to be 0. So now I bring down the -4x plus 12. Let me go ahead and bring the rest of that down. X will go into -4x, -4 times. Then multiply, I get -4x minus 12. I get a 0 remainder. So look, here it is. This is x minus 3 times x squared minus 4. Or I could write that as x minus 3 times x minus 2, x plus 2. So now I know that the roots are, one root is 3. I've got a root of -2 and -2. Okay, now let's suppose that we have 2i. We know that 2i is a root, okay? Well, if 2i is a root, then that means that -2i is a root as well. So here's what we've got. We've got x minus 2i and x plus 2i. That's, part of the polynomial. In other words, this right here is going to be a factor. This right here is going to be a factor of this. So let me multiply that out. And I get x squared plus 4. Because remember that I squared is negative 1. So you keep that in mind. And if you FOIL this out, you'll get x squared plus 4. So now let's do our division. We've got x squared plus 0x plus 4. And I'm going to divide that into x cubed minus 3x squared plus 4x minus 12. Okay. So I put the 0x in there just to keep things lined up. But here we go. X squared will go into x cubed, x times. Then we multiply and we get x cubed, plus 0x squared plus 4x. And here I get negative 3x squared. And I'll go ahead and bring down, this is 0x minus 12. Okay, now let me divide. X squared will go into negative 3x squared, negative 3 times. And then I multiply and get negative 3x squared plus 0x minus 12. No remainder. So there we did it. So here's what we've got. We've got x minus 2i, x plus 2i, times x minus 3. There. So whenever we're told that, that something is a root, we can convert it into a factor divide to find other factors, other roots. Okay, now remember this next part, 9, we want to find asymptotes and intercepts. Okay, now remember, when we're talking about, let's say, horizontal asymptotes, we have these cases that, first let's think about vertical asymptotes. When we talk about vertical asymptotes, generally speaking, what we're going to do is we're going to set the denominator equal to 0. Okay, so if we've got P of x over Q of x, we're going to set Q of x equal to 0. Okay, now if we want to know the Y-intercept, let me just do this. If we want to know the Y-intercept, that's when we just replace the x with a 0. If we want to find the x-intercept, generally speaking, what we're going to do is just set the numerator equal to 0. So these are very straightforward things that we can do just to, to find the vertical asymptote, the y-intercept, and the x-intercept. Now, to find the horizontal asymptote, we have cases. If the degree of the top is less than the degree of the bottom, then it's the x-axis. Okay? If the degree on the bottom, if the degree on the top is equal to the degree of the bottom, then it's the leading ratio of the leading coefficients. Okay? If the degree on the top is greater than the degree of the bottom, then there's no horizontal asymptote. You divide to find the slant. Okay, so So let's see how these would work. First of all, for part A, okay, for part A, we have the y-intercept is just going to be negative 1/5. 1/5. Okay, that's the y-intercept. Now, the x-intercept, we set the numerator equal to 0, and we get 1/3, 0. Okay. The vertical asymptote, set the bottom equal to 0, and we get x equals negative 5/2. Horizontal asymptote, the degree on top and the bottom are the same, so it's going to be y equals 3/2. Yeah. Okay, now, let's look at the next one. Y-intercept is going to be 0, 1. I'm just putting a 0 in for x. X-intercept is going to be 1/3, 0. Vertical asymptote, we got two of them. X equals plus or minus 1. Horizontal asymptote, y equals 0. Or, in other words, the x-axis. Okay, now, let's look at the next one here. We've got y-intercept. Okay, that's going to be 0, 10. X-intercept. X-intercept, that's going to be, there's going to be two of them. X equals negative 5, negative 2. So negative 5, 0, negative 2, 0. Okay. Vertical asymptote, x equals negative 1. Now, notice the degree on the top, it's bigger than the degree on the bottom, so I need to divide to get the slant asymptote. Okay, so let me see if I can squeeze that in over here. I've got x squared plus 7x plus 10. Divide it by x plus 1. So x will go into x squared, x times. This is x squared plus x, 6x, bring down the 10. X will go into 6x, 6 times. And at this point, we're at the end of the line. Our slant asymptote is the quotient. We don't have any regard for the denominator. The remainder. Okay. Now let's move along to the exponentials and logarithmic functions. Okay. Now, first of all, we want to convert to log form. So remember, I said you can think of that as taking the base on the 1, the exponent, and when it crosses the equal sign, it becomes the base of a log for the other. Okay? So really, you're applying the inverse relationship to both sides. So this is going to be x equals natural log k. Over here, I've got k is equal to log base 10 of s. Okay, same thing down here. We have 8 equals 2 to the third. Here we have 8 equals 10 to the k. And 8 equals e to the p. Yeah, that's all. It's pretty easy if you think of it that way. Now, let's look at evaluating logs. Log base 2 of 16 equals. Well, this is saying 2 to what power equals 16? Well, 4. 10 to what power equals 100? 2. 3 to what power equals 81? 4. Okay, now we want to solve each exponential equation. Okay, remember you isolate. So we have 2 to the x is equal to 9. Log. Bring around the x. And solve. Yeah, there it goes. Isolate, log, and solve. Now you could, from this point right here, you could apply log base 2 to both sides. And, you know, you can use your change of base formula to see that these are the same. Over here, you isolate, log, and solve. Yeah, like that. Down here, the same thing, isolate, log, and solve. So I would do this. I would say x plus 1 equals log 8 over log 5, and then subtract 1. Yeah, there it goes. Okay, now for the log equations, you want to combine, convert, and solve. So you use your properties of logs, and remember your properties of logs. Log u plus log v equals log uv. Log u minus log v equals log u over v. And log u to the r equals r log u. Yeah. So these are properties of logs that you really need to know those. So we isolate, or we combine. So I've got log base 2 of 5x. Combine, convert to exponential form. So you get 5x equals 2 to the third, and then solve. Now, normally, also, you want to test to make sure your answers are not going to put you in a situation where you end up taking the log of a negative number. Okay. And if that happened, you would reject the solution. Okay, now on this one, we combine. So we've got log base 3 of x over 4. Convert. 3 to the third is 27, and then multiply by 4. Yeah, there we go. Okay, now let's drop down here to the application here. We've got a model, population of 500 grows at 2% annually. So that's going to be, the population is going to be 500, 1.02t. Find the population after 10 years. You just plug in. How long will it take for the population to double? So you solve this equation. Okay, so divide by the 500 and you get 2. Log both sides. And then solve for t. Yeah, like that. Okay, there we go. Okay, now we're on to conics, and we've got these various conic sections, and we just recognize what type we have. This first one is a parabola opening up. Its vertex is 0, 0. To get to the focus, we go up 2 units. Okay? Because remember, this is 4 times 2y. To get to the directrix, we go down 2 units. Okay? Now, I realize I'm going through this very fast, but this is just meant to refresh your memory. Now, this next one, B, that's a parabola that's opening to the right. Still, the vertex is 0, 0. However, this time, now remember, this is 4 times 3. So we're going 3 units to the right. And for the directrix, we're going to be x equals negative 3. So we're going 3 units to the left. Okay. Now, this next one, parabola opening up. Okay, so, but this time the vertex is 1, negative 2. And remember, it's opening up. So we're going to say 1, negative 2, plus 1. The directrix is going to be y equals negative 2 minus 1, because this is 4 times 1 in here. Okay, here's a parabola. It's one of these left or right opening ones, and this one's opening to the left because of this negative right here. So this is 4 times 5, and it's a negative in front. So here is the vertex. The vertex is going to be negative 1, negative 3. Now, we have to be careful because this is opening to the left. So to get to the focus, we're going to move to the left. So here we go. We've got negative 1. Whoops. We've got negative 1. And we're moving to the left 5. And the y hasn't changed. As far as the directrix goes, it's going to be x equals negative 1 plus 5. Because this is opening to the left, so we're moving to the right to get to the directrix. Okay, so these are all parabolas. Okay, now we switch gears, and now we're looking at an ellipse. Here's an ellipse. This is an ellipse, and notice that the bigger number is 9, so the major axis is the vertical. So, but here is the center. The center is going to be 1, 7. Now, from there, to get to the vertex. To get to the vertex, we've got 1, the x isn't changing. We're going to go up 3, so it's 7 plus or minus 3. Up 3, down 3, to get to the top vertex and the bottom vertex. And then we've got 1, 7 plus or minus c to get to the focus. And remember, c is equal to the square root of 9 minus 4. So it's plus or minus the square root of 5. Okay, this next one, okay, we've got 1, negative 7. And this time the bigger number is under the x. So here's what's going to happen. We're going to have 1 plus or minus 4. Those are the vertices. And then we have 1 plus or minus c, where c is equal to the square root of 16 minus 9. Gives that square root of 7. Okay, yeah. Okay, so these are ellipses. Okay, then we have hyperbolas. And we recognize the hyperbolas because, they've got a minus between. So hyperbola. Okay, so here's what we've got. We've got, okay, the positive number. The positive is the x term. So here's what we've got. We've got 1, 7. Now, to get to the vertex, we're going to say 1 plus or minus 2. And then to get to the focus, we have 1 plus or minus c, where c is equal to the square root of 9 plus 4. Okay. So it's a little bit counterintuitive. You would think with the hyperbola you would subtract 9 minus 4 because it's got a minus in there. But no. Okay, now for the next one, we've got 7, 1. Now remember, this time the y is going to be affected. So we're going to have 7, 1 plus or minus 5 for the vertices, and then 7, 1 plus or minus c, and c is equal to the square root of 9 plus 25. Okay, so this next one, we can tell it's going to be an ellipse because, you know, you've got 4x squared and you've got 1y squared. They're different. 4 and 1 are different, but they're the same sign. So that tells us, okay, we've got an ellipse going on here, but I don't really know what the foci are or anything. In other words, it's not in the form that I recognize. So what I would do is I'm going to put my x's together and factor out the 4. And then I put the y's together. And complete the square. So notice 4x squared minus 8x. All I did was factor out the 4. And then I've got the y squared plus 6y. Really didn't do anything with that. So I complete the square. Now, I put a 1 there, but really, if you consider this 4, I really added 4 to that side. Then when you half that and square it, you get a 9. So I add a 9 over here. Look, here's what I got now. I've got 4x minus 1 squared plus y plus 3 squared equals, let's see here, this is going to be a 16, I believe, yeah. Then I divide by 16, and I've got, well, if you divide by 16, what you're going to end up with is x minus 1 squared over 4 plus y plus 3 squared over 16 equals 1. And you get, you get your components here, or your center is going to be 1, negative 3. Your focus is going to be 1, comma, negative 3 plus or minus 4. See, because it's vertical. The bigger number is under the y. And then you've got 1, comma, negative 3 plus or minus c, where c is equal to the square root of 16 minus 4. So the square root of 12. Okay, now for these intersections, let's look at this first one here. We've got y equals x squared. Okay, let's see what that looks like. Y equals x squared and 16 minus x squared. So you're looking for these points right here. So you just equate these. Y equals x squared and y also equals 16 minus x squared. So put those together. Divide by 2. So x equals plus or minus the square root of 8. So that's the intersection for those. Now for the next one, we've got x squared plus y squared equals 100. And we know that y equals 4x. Okay, so let's see what this looks like. We've got x squared plus 4x squared equals 100. See, I just put a 4x in place of y. So this is x squared plus 16x squared equals 100. That's 17x squared equals 100. So x squared equals 100 over 17, and x equals plus or minus 10 over the square root of 17. There, that's it.